Hi, welcome to another Unity tutorial. In this tutorial, we're going to create a first-person character controller that can be used as the basis for the player's avatar in any sort of first-person game. So the controller has two parts. There's the mouse controller, the MouseLook script, which will allow us to move the main camera around by moving around the mouse. And then there's the character controls, which actually move the player around based on the direction that the main camera is facing. And it's also going to include a double jump mechanic with gravity as well. Okay, so I have a brand new Unity project here. I'm using Unity 2021.3.7 F1. It's a long-term service version of Unity. But I've been using this functionality for years across all of the older versions of Unity. So this should be pretty universal in terms of the version of Unity required to implement this. So the first thing we'll do is we'll set up our scene so that we have an environment to test our character and so that we have an avatar for our character. So I'm going to right click in the hierarchy window, go to 3D object, and first we'll create a plane as the walking area. And when we first bring an object into the scene in Unity, it's important to reset its position to 0, 0, 0. Now that's the origin point for the whole scene, and our entire levels should be based around this. So we should try to keep 0, 0, 0 as the center point for our scene, in other words. After zeroing out the position, I'm going to increase the scale on the x-axis and on the z-axis to 3, just to make the play area a little bit larger. Next, let's create an object for the player's character. So I'm going to right click in the hierarchy window, go to 3D object and select capsule. Again, the first thing we'll do is zero out the position on the X, Y, and Z axis. Now, our player pill here, our player capsule, is halfway through the ground. So I'm going to increase the Y position value to 1, which will position him right above the play area. Now, the next thing we need to do is set up our camera. As we can see in the game window, the camera is offset from the player's position. And in a first-person game, the camera should be within the actual player. So it's trying to show the game from the point of view of the character that you're playing as. So we need to have the main camera consistently orient itself based on the position of the player's object. And we can do this by making the main camera a child of the capsule. So to do that, I'm going to select the main camera in the hierarchy. And then I'm going to click and drag, and we're going to drop it on top of the capsule object in the hierarchy here. And you can see that it's got a little indent now, and there's an arrow here that we can close. And that's to indicate that the main camera is now a child of the capsule. So if we move the capsule around, the position of the main camera follows. But it's still offset. So if we have a look at the position coordinates for the main camera, we can see that it has an offset position on the z-axis of -10, so it's going to be 10 units behind the parent object. So we'll change that to 0. And if we look in the scene window, our camera is now inside our player, but it's right in the middle, so it's kind of like, we're watching from a GoPro that's strapped to their chest. So I like to just move this up to a value of 0.75. Actually, maybe we'll just go 0.5. Yeah, we'll go 0.5, which brings the camera to more of an eye line. Now let's select our capsule, and we're going to add a few components to this object because there are some native Unity components that the character controller will require. So I'm going to right click on the capsule collider, and we're going to remove this. Okay. Next, I'm going to go to add component, and then I'm going to type in character controller and select the character controller component. Now this component allows us to implement character controls, and it also acts as a collider. So it's sort of two components combined. It won't automatically implement the controls, but we can use this component to actually move the position of the object. So the one thing that we do need to do for this character controller component is bring the skin width to its absolute minimum. So if you mouse over the skin width variable on the character controller component here, the cursor has two arrows on either side. So when the cursor looks like that, we can click and drag left and right. So if we drag left, the value will get lower. If we drag right, it'll get higher. So we want to drag it to the left until the value stops changing, or you can just change it to a value of 0.0001, and that's just the minimum skin width. That's just going to help the ground detection be a little bit more accurate. Okay, so with that done, now let's create our MouseLook script. So in the project window, I'm going to click on the plus. I'm going to go and create a new C# script, and we'll call this script MouseLook. And once the script has been created, double click on it to open it in Visual Studio. Okay, so the first thing we'll do at the top of our class is define the variables we're going to require. So there's two variables we want to be able to see in Unity. So first we need to open an attribute, and we're going to use the serialized field attribute and follow that with the definition of a private float variable, which will give the name sensitivity. We'll also give this a default value of 2. So another thing we'll do is we'll add a tooltip to this variable so that we can hover the mouse over the variable name in the Unity inspector, and the tooltip will tell us what the variable does. So above the definition of the variable, we'll open another attribute, which will be the tooltip attribute, and the parameter that we pass to the tooltip will be what we want the tooltip to say. So here we'll say controls how much the camera will move in response to detected mouse input, right? Because that's what this value is going to control. Underneath that, we're going to serialize another field, which will also be a private float, which we call drag. I'll give this a default value of 3. Now again, on the line above, we're going to have another tooltip attribute, but this one will say controls how much the camera will continue to move after mouse input ceases. So the mouse will continue to move a little bit after we've stopped actually moving the mouse. So those are the two serialized variables we'll need. We are going to need a bunch of other variables though. So we'll have 3 variables of type vector2, which will be private. The first one we'll call mousedir. It's going to store the mouse direction. The next variable will also be a private vector2, which we call smoothing. And that's going to store the calculation for the smoothing value that needs to be applied on a frame-by-frame basis to the camera movement. Underneath that, we'll have one last private vector2, which we call result, which is just going to store the overall calculated resulting movement for this frame. Underneath that, we're going to have a private transform, we'll call this character, and that's going to store a reference to the parent of the camera. Now, they're all the variables that we want to define. We do want to define one more property though, but this will be an auto property. So we'll define a public boolean, and we'll call this look enabled. And because this is an auto property, we'll use upper camel casing for this property's name. And this value we will be able to publicly get and also publicly set, and we'll give it a default value of true. Now, because this is an auto property, we'll give it a summary so that we can have an explanation or a reference that explains what this property does as we code. So the summary for this, I'm going to say enables/disables the ability to move the camera by moving the mouse. So when this property is set to true, we will be able to move the camera by moving the mouse, and when it's set to false, we won't be able to move the camera by moving the mouse. So that's all of the properties we will need. So now we can actually begin coding the functionality. Now, we aren't going to need the start method here. We are going to need the awake method. So I've just changed the name from start to awake, and it's still a mono behavior function, just as the start and the update methods are. But the awake method gets called before the start method. So as the start method's comment here explains, we can see that the start method gets called before the update method is called for the first time. And we can can see that the update is called once per frame. So we know that the start method gets called on the first frame, basically. So the awake just gets called before that. So I'm going to change I'll turn this into a summary, and we'll say awake is called before start. Now in the awake method, what we want to do is make sure that in this particular script, we want to make sure our character variable has a reference to a transform component before the script tries to use it. So what we'll do here, and remember I said that we want this character variable to store the parent's transform, a reference to the parent through its transform component. So to do that, we'll say character is equal to, and we can get access to the transform component of the object that this script is attached to simply by writing transform all lowercase. And then to get access to the parent of this transform, we can simply write dot parent, which will return the transform component of the parent game object. The other thing we'll do here is we'll just make sure that look enabled is equal to true. So when the game first starts, we can actually look around. Okay, so we'll minimize that method now, and we'll turn the update method's comment into a summary. And I'll just add a full stop on the end too. So in the update method, this is where we actually need to calculate the movement to apply to the camera and the parent object on a frame by frame basis. So first of all, we need to get our current mouse input and store that inside our mouse direction variable. So we'll say mousedir. It's going to be equal to a brand new vector2. So it's a set of coordinates with two axes, or a number with two axes. Now, so those axes will be separated by a comma. On the left-hand side will be the x-axis, and on the right-hand side will be the y-axis. So on the left-hand side, we're going to say input.get axis raw, and the parameter will be mouse x with a capital M, a space, and a capital X. And then for the y, it's going to be very similar, input.get axis raw, and instead of mouse x, of course, we will say mouse y. Now those are default Unity inputs that are tied to the mouse cursor directions or the movement of the mouse cursor. So as we move the cursor from the left to the right of the screen, or when we move it horizontally, the x-axis will increase or decrease. If we go to the right, it will be a positive value. If we go to the left, it will be negative. And the same thing for y, but of course the screen height up and down. So if we are moving the mouse up, it will be positive, and if we move it down, it will be negative. After that, we want to multiply both axes in that variable, in that mouse direction variable, by our sensitivity value. So we can do that very simply. We'll say mousedir, and then we get the asterisk and follow that with an equal sign. And after that, we'll say sensitivity. So what that's going to do is it's going to multiply mousedir's current value, or values, because it's got an x and y axis, by this sensitivity value. After that, we need to calculate, or we need to smooth out the movement. So here we'll say smoothing is equal to vector2.lerp. So lerp stands for linear interpolation, and this needs three parameters. First of all is the value that we actually are trying to lerp, right? The value that we're manipulating. So this is going to be our smoothing value here. After that is the value that we want to move the previous value toward, right? So we want to move our smoothing value toward our mouse direction value. The last parameter we give to this is a fraction or a ratio of which to apply that by, right? So here we're going to say 1 divided by our drag value. Now that's going to calculate the smoothing. Now we just need to add that onto our current result. So we'll say result plus equals smoothing. to add the smoothing value onto the current value of result. But there will be an issue with this, specifically in regard to the y-axis, because if you push the mouse far enough up, it will eventually flip over. And same thing for pulling it down towards the ground. So we need to clamp the y-axis for our result. So we'll say result.y is equal to mathf.clamp. So that's the function we use to clamp stuff. And this will take 3 parameters. So again, we'll say result.y as the first parameter, which is the value that we want to clamp. The next value is the minimum value that can ever be. So we'll say minus 70. And the following that is the maximum value that our result.y parameter will be. So we'll say positive 70 for that one. So that's calculated all of the movement that needs to be applied on that frame, and all that's left for us to do now is apply that. So we're going to be applying it to 2 objects depending on the axis being rotated. When we move the mouse up and down, we want to apply that to the camera and not the character, because the character isn't going to be stiff as a board and rotate with their head as they move up and down. The eyes will be separate from that. But when we move the mouse left to right, we want to actually rotate the character's object so that their orientation is locked with the direction of the mouse, and that way when they press forward, they're going to start moving in the direction that they're looking. So first we'll grab our character, and then we'll get the rotation variable. So this is the parent that we're manipulating here, and we're going to say that is going to be equal to, and here we need to generate an angle. So we're going to say quaternion.angle axis. And first we pass it the angle, right? So first we'll say result.x is the angle that we want to create a rotation from. And the axis that we want to rotate around is going to be the character's up axis, right? So their local y-axis. So to get that direction in local space, we'll access the character's transform through the character variable, and then we can just say up after that. Right, so no matter which way the character object is oriented, moving the x-axis is going to rotate them appropriately. Underneath that, we're going to say get the transform of the camera, which is attached to this MouseLook script, or has this MouseLook script attached, I should say. Then we're going to access its local rotation. So we're not using rotation here, we're using local rotation because the object that we're manipulating, the camera, is a child of another object. And again, we need to use quaternion.angle axis to create a rotation around a specific axis. So we're going to say equals quaternion.angle axis. Now here, we're going to pass inverse result.y, so negative result.y, and instead of a direction oriented around the character's position, we are going to use world space for this. And this is to prevent gimbal lock, basically. So we're going to say vector3.right, which is the equivalent of east. Okay, so with all of that code set up, our player should be able to move the camera in the game around by moving the mouse. But we only want our update functionality to occur if our look-enabled boolean has a value of true. So to do this, we need to define an if statement. So at the very top of the update method, I'm going to go to a new line and then type the if keyword followed by a set of parentheses. So in the parentheses, we need to define a condition that must be met in order for the code included in the if statement to be executed. So the condition we want to check for here is that our look-enabled boolean has a value of true. So to compare the two values, we use a double equal sign, which will compare the left-hand value to the right-hand value. Now to have all of this code execute only if that condition is met, we need to encapsulate it in a set of coding brackets, like what we see for the methods. So after the parentheses, I'm going to open a set of coding brackets. Then I'm going to remove the last one and place it back in where I want the if statement to end, and Visual Studio will automatically reformat my code. So now all of this code here will only be executed if our look-enabled Boolean has a value of true. So now all that's left for me to do is save the script by pressing Ctrl S, and the asterisk at the top of the script tab disappears, indicating that there are no unsaved changes. And now we can go back into Unity, attach this script to our main camera, and test out the functionality. Okay, so I'm back in Unity. So we'll select our main camera, and I'm going to drag the MouseLook script from the project window onto the Add Component button here. And you can see we have this sensitivity value, which we can change, and this drag value, which we can change. So the other thing, just to double check, is that our main camera is a child of the player capsule, and that its X and Z values are at 0, so that it's exactly inside the player. So now let's hit play. So if I move the mouse down, the camera moves down. If I move it up, the camera moves up. If I look left, our character is rotating. If I look right, it rotates the other way. Good. So we have the mouse movement done. Okay, so now that we have the mouse movement working, we need to add the player controller. So I'm going to go to the project window, click the plus sign, select C# script, and name this new script player controller. Then I'll double click on it to open it in Visual Studio. Okay, so again, at the top of our player controller class, we'll start by defining some variables. The first few are going to be serialized, so we need to add a serialized field attribute before we define them. And then the first one will be a private float, which we call gravity, and we'll give a default value of 30. The next will also be a private float, which we call jump force, and we give a default value of 20. The next variable will also be a serialized private float, which we call double jump force, and we'll give a default value of 10. And the last serialized variable will also be a private float, and we'll call this default move speed and give it default value of 3.5 f. We will also need a few hidden variables. So our first one will be a private vector3, and we'll call this motion step, and that's going to store the amount of movement we want to apply on each frame in each direction. Then we'll create a private Boolean, and we'll call this jumped twice, and give it a starting value of false. After that, we will have a private float, which we call velocity, and give a default value of 0. Lastly, we'll have another private float, which we call current speed, and give a default value of 0. We'll also create a public Boolean called canMove, and this is going to be an auto property, which can be publicly read and also publicly set, and we'll give this a default value of true. And the summary will give this auto property here, we'll just say disables the ability to move the player character via device input. Oops, I just realized we will actually need one more variable, which will be a private character controller, which we'll call controller, and that's just going to store a reference to the character controller attached to this game object. With all of our properties defined, we can start writing the code for the functionality. Now we are going to use the start method and the update methods here, but before we use either of those, I want to inherit the awake method. As we discussed in the MouseLook script, the awake method is called before the start, which means that it's called pretty much the first method called on the very first frame that this object is active for. And in the awake method, what we want to do is we want to make sure that this reference variable here of the character controller type actually has a reference to a character controller. So the character controller that we're going to try and grab should be attached to the same object as this script. So we can just use the try get component method, and that's going to look through the components attached to this object for the one that we specify in here, and it's going to push it out. Okay, but in order for it to push it out, we need to give it a variable for it to push it out into. Okay, so we'll say out because it's going to push it out, and we'll just pass controller. We don't have to define a type here because it's automatically going to pick up the type associated with the controller variable. So it's going to look for a character controller component because it knows that's the only component that can be stored inside this variable. Okay, so that's the awake function. Now in the start function, all we're going to do here, let's turn that into a proper summary. So in the start function, what we're going to do here is we're just going to say our current speed is equal to our default movement speed. Okay, so it's just moving it off 0 so that our current speed actually has a value. Okay, now after the start method, I'm going to inherit another method called the fixed update, right? And the fixed update runs separately from the regular update. So the regular update is called once per frame. The fixed update may be called more than once per frame because it runs on Unity's physics tick as opposed to delta time. So what we use fixed update for is to apply physics and that sort of stuff. Actually, hang on, let's just quickly write fixed update may be called more than once per frame. Okay, so that's a nice little summary for it. So yeah, what we use the fixed update for is to apply physics because if more than one move step needs to happen during a frame, yeah, this is obviously how we do it because this will run potentially more than once per frame. Depending on the hardware of your computer and range of variables like that. So what we're going to do here is first we want to check if we can move. Okay, so we'll say if can move is equal to true, because if it's equal to true, we are going to apply gravity, and gravity is fairly easy to apply in this case. If our controller is grounded, then we want to keep them at a constant level, or as constant as possible. But if they are not grounded, we know that they are either they're in the air, they're moving through the air. So this is when we need to change the velocity. Okay, so first we'll open an if statement, and we're going to check if controller.isGrounded is equal to true. Okay, now this variable here can be a bit finicky. I find that moving the skin width down on the character controller to its minimum value really helps this be a bit more consistent. But if this if statement executes, then we are on the ground. So what we want to do here is we're going to say velocity is equal to negative gravity multiplied by time.delta time. So that's basically keeping us at a consistent level. This value is the time it took to get from the last frame to the current frame. So we're talking fractions of a second. We're grabbing this gravity value and basically just grabbing a fraction of it and setting our velocity to that. We'll add an else statement to that if statement. So if this else statement executes, we know that we are not grounded. That is grounded is equal to false. So in this case, this is where we actually want to modify our velocity. So we'll say velocity minus equals gravity multiplied by time dot delta time. So that's subtracting a little portion away from the velocity every time that else statement executes. Okay, so now that's all we need to do for the fixed update. So let's move down to the update now. Now in the update, this is where we're going to check for inputs and we'll actually apply our motion step, or calculate it and apply it as well. So first of all, we only want to do any of this stuff if can move is equal to true, if our player is capable of moving. And if they are, the first thing we want to check is if they are grounded. So we'll say if controller.isGrounded is equal to true, then we know that the character controller component is on the ground. Now, we've got to kind of consider all the circumstances here. This could be a frame where we've already been on the ground for, a number of frames. It could also be the frame that we've just landed on the ground. And if that's true, we need to reset our double jump flag. So we'll open an if statement here, and we'll say if jumped twice is equal to true, then we're going to set jumped twice equal to false. And then this if statement won't run again until jumped twice gets set back to true. The other if statement that we're going to check for when we're grounded is if input.getButtonDown true. Now the button we're going to check for here, the input axis we're going to check for here is called jump, which is a built-in Unity input axis, and it's associated with the spacebar. So if we press that, all we're going to do is we're going to say velocity is equal to jump force, our initial jump force. So now I'm going to, and that's all we need to do if we're grounded. So this section here defines what happens while we're on the ground. So now let's define what happens when we're in the air. Now we want to check for a very specific condition here. So for the to counter the if controller.isGrounded if statement, I'm using an else if, and what I'm going to check here is I'm going to check if jumped twice is equal to false. So if we haven't activated our second jump yet. If we haven't activated our second jump yet, then we can continue to check for the jump input, just like we did before. And if we press it, we're going to do two things. First, we're going to say our jumped twice flag is equal to true, which means we won't be able to do it again. And the other thing is we're going to set our velocity equal to our double jump force, which is slightly less than our regular jump force. Excellent. So with that done, all we need to do now, and I'm going to write this as a comment because we need to create a method for this, but we need to apply our movement after that. Once we've modified our velocity, we can then calculate the movement for the frame. And I do this in a separate method. So underneath the update, we're going to have a private void and call it apply movement. And we can even replace that comment now and just call the method so we don't forget later on. But in here, we need to do a couple of things. We need to first reset our motion step because we need to calculate a fresh motion step every frame. Then we need to calculate which direction we're going to move in and add that to the motion step. Multiply that by our current speed. Then we're going to calculate or add our velocity onto the motion step. And then we'll multiply that by delta time. So first of all, we'll say motion step is equal to vector 3.0, which will reset it to a value of 0 on the X, Y, and Z. After that, we want to grab our motion step and add a value onto its existing value. Now the value we want to add on to that is our forward direction. So we'll say transform.forward and multiply that by our input. So we'll say input.getAxis raw. And the axis we want to get here is vertical. So this axis is associated with the W and S, or the up and down arrow keys. So when we press either one of them, we are going to move forward or backwards, because this will return a negative value if we press backwards, but it'll be positive if we press forwards. So if we press W or up, positive, S or down, negative. After that, we're going to do a similar thing, but this time we're going to do it for our horizontal movement. So we'll say transform.right times input.getAxis raw, and then horizontal. So we are multiplying our inputs by the relevant direction. After that, what we want to do is we want to multiply our motion step by our current speed, and we also want to normalize the value. So normalize means to bring each value down to like a ratio between 0 and 1. or the equivalent ratio between 0 and 1. So here we're going to say motion step. Motion step is equal to current speed multiplied by motion step dot normalized. So that's going to normalize motion step and then multiply it by our current speed, and it's going to assume that value. Then we'll say motion step dot y, and we're going to add our velocity onto whatever that value currently is. And then lastly, we'll say controller dot move. We'll pass it our motion step and multiply that by time dot delta time. And with all of that in place, we should have a functional player controller. So I'm going to hit Control S to save that, and we'll go back into Unity to test it out. Okay, so I'm back in Unity. We'll select our player capsule, and we'll drag our player controller script onto the object. Make sure it's got all the appropriate values. So gravity of 30. We've got an initially strong jump force, slightly weaker double jump force, and then a default movement speed. And then, of course, it's got a character controller with the skin width brought right down to the minimum. With all of that done, let's hit play. Okay, so I can look around. And now if I press W, I start moving in the direction I'm looking. If I press A, I move left. If I press D, I move right. If I press S, I move back. And it's all oriented around my current direction. If we press space, we jump. If we press space and then again, we do a double jump, and we can see that we can only do a second jump once until we've landed again. So there you go. That is the basis of a first-person controller. And you can use this for walking simulators. You can turn this into a first-person shooter game, a battle royale, any kind of first-person game. This is the basis of. So thanks for watching. If you enjoyed the video, please leave a like and subscribe for more game development content in the future. Hope you learned something from this video and you found this useful.